Hi, there's a fire. I don't know how it started. If you can give your Reading Street.
Hold on. Give me that address again.
Responders are trained to handle emergencies. The goal is always to prevent loss of life and property. But with some materials, such as natural gas, taking the right action is critical to protecting everyone's life, including your own. Procedures, equipment, and terminology shown in this program may be different than those used in your community. The focus is on understanding natural gas and responding to any potential danger. Throughout the program, you'll see a little blue icon popping up, highlighting a point which is extremely important to know. And at other times, a red icon, emphasizing conditions which are extremely dangerous and need to be remembered. After different sections of the program, there will also be some brief review questions to make sure you have a grasp of the key points. Most of us know that oil comes from the decaying fossil remains of prehistoric plants and animals, but aren't aware that natural gas also comes from these sources. Sunk into oceans millions of years ago, under high temperatures and pressure, chemical reactions created oil and gas, composed primarily of methane from these remains. And as mud and sand turned to rock, the gas would be trapped in pockets beneath the surface, until it was discovered and converted into usable fuel. Similar to an oil well, by drilling into these pockets, the high pressure forces the natural gas through the pipe, and once brought to the surface, it's collected and refined to become usable. The familiar substance is found in millions of homes and industrial sites where it burns in appliances. Or does it? Before you can control natural gas, you need to know its unique properties. They can either keep you out of or get you into trouble. A minute ago you saw gas burning. Well, not really. The lower explosive limit, or LEL, falls just below a 5% gas-to-air mixture, showing a yellowish flame. As the mixture goes up, the flame turns bright blue, burning cleanly at the optimum mixture of about 10%. When we get near 15% gas to air, the upper explosive limit, the flame extinguishes. It's too rich to burn. This explosive range is an important concept because later you'll see how it will affect your course of action in responding to emergencies. A temperature of 900 degrees can ignite natural gas in the proper mixture. How hot is that? A cigarette tip burns at about 900 degrees when lit, obviously hot enough to ignite natural gas. But other common activities, like operating a light switch or adjusting a thermostat, can also do it. Likewise, in the vicinity of a gas leak, many of the devices you use in your job can create dangerous electrical discharges. A pager or cell phone can generate enough energy to ignite leaking gas, and using a radio is just as great a danger. When natural gas burns cleanly, it produces heat, water vapor, carbon dioxide, and trace amounts of carbon monoxide. If it isn't burning cleanly, as with any fossil fuel, it produces larger amounts of carbon monoxide. This potentially lethal emergency will be examined later in the program. Now, what if the gas is unlit but still flowing? If I came into the room now, how would I know this? If it's turned up really high, I might hear it. But I can't miss that smell reminiscent of rotten eggs. It's commonly accepted that natural gas does have a strong odor, and that fact is misleading. Natural gas has no odor, or taste for that matter. The smell is produced by chemical additives, either mercaptans or sulfides, which are absorbed by the gas, yet have no effect on its ability to burn or heat. So the smell is entirely there for detectability when gas is escaping. A common misconception about natural gas is that it's poisonous. Not true. However, it can be lethal if the atmosphere becomes so concentrated with natural gas that almost all oxygen is displaced. Now here's a question. Is natural gas heavier or lighter than air? Two different balloons filled with two different gases. Which one is natural gas? Natural gas is lighter than air. This balloon is filled with propane, which is derived from processing either natural gas or petroleum, and by contrast, it's heavier than air. So when propane escapes, it either pools or puddles on the ground. We'll look at dealing with escaping propane later in the program. Let's review some of the important concepts about the properties of natural gas. True or false? Natural gas is toxic. False. What is the lower explosive limit for natural gas when mixed with air? 5%? 10%? 15%? 5%. True or false? Natural gas has no odor at all. True. The smell is from chemical additives. Is natural gas heavier or lighter than air? Natural gas is lighter than air.